Okay, let's look at 10.1, which is square root and higher order roots like cube roots and higher than that. But before we actually look at the problems, I want to kind of look at where this comes from. So you might have seen this little chart before, but we start with the group of all numbers in the world. And then they are split up into two types. You either have real numbers or not real numbers, which are also called imaginary. And then within the real, you have either rational or irrational numbers. So there are, mathematical definitions for these. But if you really want to be able to tell the difference, I always say, and simple thought is that just what do the words rational and irrational mean? If you're talking to a rational person, they make sense, you understand them. If you're talking to an irrational person, they do not make sense and you have no idea what they're talking about. And so these you can tell the difference between, even though these are both radicals, we know the square root of 25 equals 5. That's a perfect square, one we can do in our head. And so that's considered a rational number. But if you held a gun to my head and said, what's the square root of 17? I wouldn't really know because it's a decimal and I would need a calculator probably to figure it out. So that's an irrational number. And then not real or imaginary numbers are anytime you have the square root of a negative number. And we'll talk about imaginary numbers later. We'll learn that we're going to use the letter I and some stuff like that. But for today, you just need to know that you can't take the square root of a negative number. If you put that into a calculator, it'll say error. And so when you take the square root of a negative number, it's imaginary. And I'll explain that a little bit more on down here. So first we're going to look at square roots. And so perfect square roots come from the opposite of squaring a number. So if we had 2 squared is 4, then the square root of 4 is going to be 2. And so to list your perfect square roots, you have the square root of 1, 4, and so on. And the way you get those is that 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. Actually, I'm doing these backwards. Let's mark this out. So the square root of 1 is 1 because 1 times 1 is 1. The square root of 4 is 2 because 2 times 2 is 2. The square root of 9 is 3 because 3 times 3 is 9. And so you can get these by just listing your numbers. And you could keep going on into infinity and squaring them. So this 4 times 4 is 16. So the square root of 16 is equal to 4. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And you got 100 and 121. And you can keep on going, but usually those are the main ones that you're going to see. Now the square root of 4 is equal to 2 because 2 times 2 is equal to 4. And so when you go to look at our square roots here, well, these first ones are telling you to label them. Are they rational, irrational, or not real? And so when we look at the square root of 25, we know that that's 5. So that's actually a rational number. It makes sense. We know what the square root of 25 is. The square root of 49 is 7. So again, that's a rational number because we know what the answer is. But when I look at square root of 27, that's not a perfect square. So it means its answer is going to be a decimal. I don't know what it is. I'd have to have a calculator to find out. So this is a irrational number. And then this last one, the square root of a negative. Anytime you try to take the square root of a negative, it's not real. And we'll talk about that a little bit more later on. So the first part of your assignment is just going to tell you to label them rational, irrational, or not real. And then the second part is going to have you to solve. So let's look at this first one. So here the negative is outside of the square root sign, so that's okay. This negative is just going to come down, and the square root of 36 is 6. So the answer to the negative square root of 36 is negative 6. But if the negative's inside, you can't take the square root of a negative number and get a negative number. And the reason why is that 5 times 5 is 25. But if you have negative 5 times negative 5, you get a positive 25 again. And so you can't take the square root of a negative because there's not any two numbers that are the same that would give you a negative. Because a positive times a positive is positive, and a negative times a negative is positive. So you can't take the even root of a square root. So when you see the square root of negative 25, you just write not real. Later on in the chapter, we'll work with what to do, but for right now, you just write not real. You can't do that. This next one, the square root of 0.36, that's one you might think you can't do in your head, but because 36 is a perfect square, 36 is 6, 0.36 would just be 0.6. So if you have an even number of decimal points, you can just take the square root. Then this last one's a fraction, and you don't have to show this step, but the square root of 9 over 25 is the same thing as the square root of 9 over the square root of 25. So that would be 3/5. Or you just square root the top and square root the bottom. And so if they're perfect squares, you've got your list over here that you can look at them. So square roots, square means 2. So when you don't have a number outside the parentheses, you're assuming it's a square root, and you're looking for what number times itself will give you that square root. And again, a negative won't work because 2 negatives make a positive. Let me slide this up. But now let's look at cube roots. So again, to get your cube roots, you can list your numbers. We don't need to do quite as many. But instead of squaring it, we're going to cube it. We're going to do it 3 times because cube means 3. So 1 times 1 times 1 is 1. So the cube root of 1 equals 1. So this little 3 up here is what makes it a cube root. If it doesn't have a number, it's assumed to be a 2, and it's a square root. The next one will be 2. So I'm really doing 2 times 2 times 2 is 8. So the cube root of 8 is equal to 2. 3 times 3 times 3 is 27, so the cube root of 27 is 3. 4 times 4 times 4 is 64, so the cube root of 64 is 4. And then 5 times 5 times 5 is 125, so the cube root of 125 is 5. So a cube root is asking you what number times itself 3 times would give you that number. So let's look at 3 of these. So the cube root of 8 is just 2 because 2 times 2 times 2 is 8. But now let's look at a negative. Now with square roots, you can't have a negative because a negative 2 times a negative 2 is a positive 4. So you can't have the square root of a negative number. But a cube root, if we do 3 negatives, negative 2 times negative 2 times negative 2 is negative 8. So when you have a cube root, you can have a negative. So the cube root of negative 8 is negative 2 because 3 negatives give you a negative. And so the same thing on this last one. This negative out front is just going to come down. It stays there. And then the cube root of negative 64 is negative 4 because negative 4 times negative 4 times negative 4 is negative 64. But then we have a double negative, which means our final answer for that one is just going to be a positive 4. Okay, so let's think about higher order. So what the rule really comes down to is even roots can't be negative. So 2 negatives make a positive, 4 negatives make a positive, 6 negatives make a positive. Any even number of negatives can't be positive, but an odd root can be negative. Does that make sense? So fourth roots, so when we look at this fourth one, it's the 4th root of 81. So we're going to think what number 4 times is equal to 81. And if you don't know right off the top of your head, or if you've got a calculator, you can do it, but just start guessing. So let's look at 2. So if I did 2 times 2 times 2, 2 times 2 is 4, times 2 is 8, times 2 is 16, so it can't be 2. So let's try 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So the fourth root of 81 is 3. So you're just kind of thinking in your head, what number times itself 4 times would give us that number. So the fourth root of 81 is 3. But the fourth root of negative 81, even if you made these all negative, you'd still end up with positive. So because this is even, you can't have an even root of a negative number, so you write not real. Okay, let's look at the fifth root of 32. So that's asking you yourself, what times itself 5 times? So if you don't know, just start guessing with 2. So let's look at 5 2s and see what happens. So I have 5 2s. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the fifth root of 32 is 2. But now let's look at the fifth root of negative 32. Because this is odd, 5 negatives equals negative 2. Whoops. So because this is odd, you can have the fifth root of negative 32, and your answer is just negative 2. Let's look at the sixth root of 64. We can kind of cheat here. 5 of them came to 32. So if you did another one, it would be 64. So the sixth root of 64 is 2. But the sixth root of negative 64 is not real because this is an even number there, and you can't have an even root of a negative number. So if you continued going, 7 would work for a negative number, 8 would be not real, 9 would work, 10 would be not real. We won't go up that high, but so the takeaway here is that an even root of a negative number is not real, but an odd root of a negative number will work. So try to work the practice problems on 10.1.